Standard 9.2, Interpreting Common Functions and Their Graphs Using the Language of Calculus. Alright, so here in this problem we are given three functions, f of x, g of x, and m of x. And before I even look at the questions, let's just sketch a graph of each one, at least a rough sketch so we know what's happening. So our first function is f of x, and it's an exponential function. And it's negative. So if you need to, you can go ahead and plot some points to get an idea of what the graph looks like. But positive 3 to the x would be a growth function. Negative 3 to the x is a reflection of that. So it kind of looks something like this. So this is f of x. And f of x has an asymptote because it's exponential on the x-axis. Alright, our second function is g of x, and that's 2 to the x, and this is also exponential growth, but it's positive, so we are going to be going above our asymptote there. And again, that's just an approximate graph. And our last function, m of x equals 4, that's a constant function, so here's m of x. Just label that, and then I'll go back and label g of x. Okay, so let's answer some questions here. The first question says, what's the distance between f of x and g of x when x is equal to 3? So when x is equal to 3, let's just approximate where that is. Let's say x is equal to 3 right around here. So we're trying to find out how far away this point is on g of x from this point here on f of x. And in order to do that, we need the y values. And so how do we find a y value? We plug in x, and the x value that we're plugging in is 3. So g of 3 is equal to 2 to the third, which is equal to 8. So this point here is at 3, 8. And f of 3 is equal to negative 3 to the third, which is negative 27. So this point here is at 3, negative 27. Now how far apart are these? Well, look at the y values. What's the distance from 8 to negative 27? And you can always subtract the upper minus the lower to get that distance. So this works out to be 35. The second question says, what's the distance between f of x, which is the red, and the x-axis at x equals negative 1? So let's evaluate f of x at negative 1 here. F of negative 1 is equal to negative 3 to the negative 1. And the negative makes this the 1/3, so this is negative 1/3. So this point here is negative 1, negative 1/3. How far is that from the x-axis? Well, the y value is negative 1/3, so it's 1/3 unit away. So when we're trying to find distance, we're really just comparing the y values between the two things we want the distance between. Question number 3 says, what's the minimum distance between f of x and m of x? When does this occur? So what's the smallest distance basically between the red graph and the green graph? Well, the further to the left we go, the closer the two graphs get to each other. This green graph is 4 units above the x-axis. Now, our red graph will never actually reach the x-axis unless we go all the way out to negative infinity. So there's two ways that you can really answer this question. You can say there's no minimum distance because it will continue to get closer and closer and closer and closer and infinitely closer. If you went infinitely forever, though, to the left, you would be 4 units away. So you could say one of two things. You could say that there is none, or you can say that the minimum is equal to 4 at x equals negative infinity. All right, the next question says, on what interval is the distance between f of x and g of x increasing, and at what interval is it decreasing? So f of x and g of x are the red and the blue. And we read graphs from left to right. So as we read from left to right, let's start all the way on the left end here. What's happening to the distance between the two graphs? And you can see that the distance between them is getting bigger and bigger and bigger and bigger. And so the distance is always increasing. Again, we're reading from left to right. So on what interval is it increasing? From negative infinity to infinity. When is the distance between them decreasing? That answer is never. Finally, it says let h of x equal g of x minus m of x. So now we're comparing g and m. When is the difference positive? When is the difference negative? Well, g of x is the y value of g, and m of x is the y value of m. Y value. Okay, so we're comparing the y values. And when is the difference going to be positive? So h of x is positive when g of x is greater than m of x, because when you subtract two numbers and the first one is bigger than the second, then your difference will be positive. And h of x is negative when the second number is bigger, so when m of x is greater than g of x. So let's look on our graph and see when g of x is bigger than m, and then let's see when m is bigger than g. So we're comparing m and g. M and g are the green and the blue. So in this region, the green is bigger than the blue because it's higher up, right? And in this region, the blue is bigger than the green because the blue is higher. So the question is, where is this point that kind of separates those two regions, that point of intersection? Well, how do we find a point of intersection? We find out where the two functions are equal. So let's set g of x and m of x equal to each other. So g of x equals m of x when 2 to the x equals 4, or when x equals 2. So this point has an x value of 2. Now the y value is 4, but the y value is not so important. So let's look at the yellow region. In the yellow region, m of x is bigger. And m of x is bigger all the way from negative infinity to the x value of 2. So let's go back down here. When is m of x bigger? From negative infinity to 2. And when is g of x bigger? G of x is bigger when it's higher than m of x. That's in the blue region, and that's from the x value of 2 to infinity. So this is from 2 to infinity. So when you're looking for which one's bigger, you're really looking for which graph is higher. And when the first graph is higher than the second, then your difference is positive. And if it's vice versa, then the difference is negative. This is standard 9.2, interpreting common functions and their graphs.